The VEX line tracking sensor allows the robot to tell objects or surfaces apart based on how dark or light they are. It shines a beam of infrared light out onto the object and measures how much light is reflected. The line tracking sensor is an analog sensor, and it returns values in the range of 0 to 4095. Darker objects reflect less light and are indicated by higher numbers. Lighter objects reflect more light and are indicated by lower numbers. Okay, so here's one of my LineTracker sensors. I've already plugged it into the Cortex. I'm just going to unplug it so you can see what that looks like. It's another one of these 3-wire sensors, and it goes into one of these older 3-wire legacy ports. So just make sure you line up the groove on the sensor with the Cortex and slide it in so that it goes all the way in there. Back here in VEX Code Pro V5, if I go to my setup here, I've already added a line sensor and called it line 1. And just to make sure, and I've set it's in slot C, but if you just go add a device, it's a 3-wire port and it's a LineTracker. So then just plug which spot you put it in and give it a name. I'm going to cancel that. Okay, here's some simple LineTracker code to get you started, and I believe I put this on the classroom assignment, so you can just copy and paste it, but we're going to start with a while true statement, which just allows us to keep doing something over and over again. We're going to print out the sensor value with this line. This line is going to help it so we don't get a flashy, weird printout. It kind of makes it a nice constant flash out. And we've got a very simple if statement here. We're saying if the line 1 value is less than 45, then we're going to spin a motor. Else we're going to stop a motor. So I'll help you understand where this 45 value comes from next. Okay, so here's my sensor. I put a piece of white tape here, and I have the dark Chromebook cover for some contrast, and you'll be running yours on the lab tables in class that have a similar black to white contrast. And before you attach it to your robot, you want to do this and see what basically your threshold value is going to be. That number 45, if I run my little program here, my line sensor value is 70 when it's just pointing in the air. When I put it over the darker part, I'm getting values of like 67, 65, somewhere in that range. I want to keep it very close, just like a 16th or an 1/8 of an inch off. And then when I go over the tape, I'll get values of 31. And you can hear maybe in the background the engine kicked on. But when it's on the dark part of the Chromebook, getting values again of, put a little closer here, trying to move that around. Something I was getting like a 60 before, and I'm getting, it depends on where I go and how the light's bouncing off of it a little bit. But roughly it was about 60. Now it seems to be slightly less. And on the tape was about 30. And the way I came up with the 45 value is add those two together and divide by 2. And that'll give you what I would call your threshold value that you want to compare it to. So if the LineTracker is on the green or on the white tape, then we want the motor to run while it's sensing that 34, which is less than 45. But as we move off into the darkness, and now it's in the 50s, it's going to turn off. Okay, one concept we want to consider here is when you do this and you track a line, you're going to actually have 3 sensors. So they're going to be right next to each other. And you want to start with the middle sensor on the white line. And the way you want to think about this coding-wise is you have a statement that says if the middle tracker is less than 45, then we know we're on the line. And then we can just say turn both motors on, and the robot will start moving forward. And you see there's a turn coming up, and I want you to kind of keep an eye on what happens here. So as I come up to the turn, the tracker that's on your right is going to hit the white line, right? So that would be this one right here. So now if this tracker is less than 45, it means we're going to want to turn the robot. So we'll run the motors maybe at different speeds, and we're going to slowly get the tracker to get back on the middle and then go forward again. So again, you just have to, I want you to think about that conceptually. You got the middle on there going straight. As soon as a different one goes on, then you're going to want to turn it. In this case, it's on my left. If the left one goes on, I bump it left. And if the right one were to go on, I'd bump it right. So step that.